Today's title of the session is called Tom Riddle Diary and Severus Snape. So these are the names from the Harry Potter. So it's one of the concept that goes back in the past. Okay, so I just wanted to make an analogy of going back to the past with the internal assessment. So let me quickly show you what I mean by the IA Tom Riddle Diary and Severus Snape. Okay, so one of the main theme, I think, in the second book is talking about writing a journal with another character called the Tom Riddle Tom Riddle with between Harry Potter and Tom Riddle. And then the reason I'm mentioning about this is that the also for the Math IA there is a older version of Math IA. So if you refer to the older version of IA, you can actually gain some insight about the internal assessment. So that's what we are going to talk about at first. So before the IA, we had something called a math portfolio. Okay, so that was, I think, to my memory, was before 2016, 12, something like that. I don't quite remember the exact year, but it was before then when we were doing the internal assessment with the portfolio, and then it was also the essay based. But what was it different? Okay, what was different from the internal assessment now is that it had topics. They usually give you a topic for type 1 and type 2 essay. So type 1 is a mathematical investigation, which was more of a pure math. So that was more, I would say, analogous to analysis and approaches. But type 2 is mathematical modeling, which was to associate with the AI, right? The application and interpretation. So beforehand, when people had to write an essay about it, they were given the topic, you see. So they were given the topic, for example, to analyze how the vaccine works in the course of a viral illness and its treatment, etc. So they were given the topic and also given the steps to write the essay, right? So this is my math portfolio back in 2009. So this is my Tom Riddle diary. Okay, so why I'm talking about this is that there are plenty of topics that was already given in math portfolio, and I think it's great if you haven't chosen your topic or do not know how to write a mathematical paper for the high school. I think it's very nice. It's very nice to attempt some of the portfolio past topics and see how they describe the topic, how they try to give you the order of writing, so that we can apply that to our internal assessment as well. I'm not asking to plagiarize, but it's just good to get some insights from the already existing paper that IB has made, that because that's probably going to be something they would want the students to write. So for example, they give you modeling sunrise, and then they give you not only the topics to write, they also give you steps to write. So that's probably the steps that we need also, the logistic of writing for the internal assessment as well. So it's always nice to have something exemplary. So yes, so not only the ideas, it gives you direction. And yeah, often also what it does is that it not only talks about the topics for the internal assessment, it also gives you the paper 3 sort of a type of questions. So it's a super nice. And so for the theoretical part of the portfolio that we can gain some insight will be from type 1. Type 1 focuses more of a theoretical proof mathematical idea, where type 2 will talk about more likely an application where they actually use this math in real life. So there is a very nice touch on those portfolio that we can definitely implement for the IA. So that's my first suggestion. If you're running out of topics, referring to the math portfolio is good idea. Yes, it's got a bunch of paper 3 types of questions as well. It's got the I don't know, cubic formula for the type 1, I think, the task. And then this is also a very, very popular function. It's called the damping oscillation, which is a very, very important function for many physics equations, such as wave equation And not only does it give you the topic, it gives you the guideline of how you should write such topics. So it's actually very, very nice a way to gain the insight. So what I wanted to talk about with the Tom Riddle diary reference is that yes, for writing the IA, you can actually go back in the past materials of the IB for math, such as the math portfolio, and then gain some insight. Okie dokie.
Okay, but can I use the same topic?
Oh well, here's the thing. So that's what I also was talking about the first lesson, because yes, you may. Okay, because if you think about, for example, Harry Potter, okay, and then the Lord of the Ring, even though they may look very different storyline, the structure is very similar, right? They have a protagonist such as Harry Potter and Fodor, and then there's a helper, there's it's Gandalf, and Gandalf is the Lord of the Ring, and then Dumbledore, exactly. So it's a very similar structure. So what I'm saying here is, even if you choose the exact same topic, let's say that I want to talk about the sunrise for my internal assessment, obviously you're not going to write step by step exactly identical, because that would be plagiarism. But if you get the structure and then write on your tone, on your own tone, on your mathematical expression, if you change those bits, that's not going to be plagiarism. That's just getting the idea. So there's a subtle niche difference between getting the idea versus the plagiarism. So and then that boundary would usually be determined by your school teacher. So what you need to make sure is always consult with your teacher and then ask, okay, so I got this idea from this math portfolio, but I try my best not to make it as identical as possible. I just gained some insight of the key parts here, sunrise, and for me, instead of working with, let's say, I don't know what city this is going to talk about, let's see, Geneva. Instead of working with Geneva, I will work with, for example, the sunrise in Seoul. Things like that. If you need to definitely make some change so that it is going to be eventually your own document, and that's absolutely fine. And back in the day when they were writing the math portfolio, they were given the same task, and then everyone had to write the same topic. But obviously, all the paper was different because it was each individual's different essay task. You see, so you can get the idea and then start writing on it, but obviously it's going to be produced hopefully very differently, and that's okay. But I cannot tell you that it's going to be 100% fine, because at the end of the day, this is going to be assessed by the school. So your best way to get the way to verify whether this is okay to get idea from the math portfolio is to consult with your teacher directly. That's always I recommend to students. Okay,
Okay.
good. So that's the first part where we can get the idea. So I think this is very beautiful there, and obviously they're get very carefully chosen. They're very carefully chosen by the IB, because these are very exciting mathematical ideas, and there are so many, and I think we never run out. Okay, if you just choose within the portfolio. But also, let's have a look at the another source of inspiration. Okay, there's I would refer the exam questions as a Severus Snape, right? So one of the main character from Harry Potter, which appears to be very mean and menacing, but turns out to be a very helpful guidance to the main character Harry Potter, right? So he changes his sort of a role from mean to very very a very good man, right? And that's what I would say for the exam questions as well. One of the there's some challenging math exam questions already appeared in paper 3 mostly, and then there's a reason for the IBO has chosen those topics, because those are very exciting mathematical ideas, and I think it's very good to elaborate to very good to extend it from that chosen exam questions and then start writing on either for the internal assessment or even for the extended essay, because these are actually very, very nice topics. So let's have a look at one of the paper 3 main exam question. I'm not going to solve it during the lesson, but I just want to tell you what this question is actually all about. It does not tell you what this topic is, but this is actually a very popular mathematical idea. Let me quickly show you. So what you had to do, right, in the test in the 2003 May, okay, you were given this nice function fx is equal to x to the power of n e to the power of negative x. And then what you had to do was actually to integrate this. We had to integrate. We actually had to do the improper integral. All right, let's have a look. So, if I rewrite this expression with the function, it would have been given from 0 to infinity, x to the power of n, e to the power of negative n dx. Okay, and then you know what? They asked me to, okay, why don't you plug the n equal to 2, sorry, n equal to 1, n equal to 2, n equal to, for example, 3, right? So that's how they asked me to integrate and then show the pattern of it. Okay, so for example, let's quickly check your integration skill, my friend. If I was given n equal to 1, then this improper integral would have been from 0 to infinity, x times e to the power of negative x. And I just want to ask you, what method of integral would you like to do here? I will give you three techniques. There's a fundamental theorem of calculus that you already know the integral because of the differentiation. You have integration by substitution, and you have integration by parts. So out of those three, what method would you like to apply here?
I honestly forgot everything about integration.
Sure. So this is actually integration by parts. Okay, so because often, when you're in the, let's say, product of polynomials and exponential functions, you often to do with the integration by parts. Not always, but this time, yes. So that's lovely. That's lovely. So, you can do that. So if you do of this improper integral, after having done that, you do the definite integral, but you send x to the positive infinite, no problem. I'll leave that as an exercise. A very, very nice practice for the just general integral as well as the paper 3. Let's suppose we have done that, then you will end up getting 1. Okay, but here's the thing. I want you to see a pattern. Okay, so look, a1 was 1, a2 was 2, a3 was a 6, and there is a sequence of numbers. There were some interesting pattern that we actually saw these numbers of a sequence, such as a 1 to 6. Can you guess what the A4 is going to be without having done the integral? So you know what? Let me change the form a bit more interesting so that you can actually spot the pattern. Like, check this out. For 2, let me change that as a product of 1 and 2. Oh, wow. For 6, let me change that as a 1, 2, 3. Oh, hold on a sec. So what do you see? What pattern do you see out of these numbers?
So it's ascending by. Wait, so n4 is gonna be 1 times 2 times 3 times 4.
And that is often known as the factorial. So now this
Oh.
is going to be 4 factorial. And this is actually a very interesting representation of the factorial, because so far we've been just referring to the factorial as just a product of numbers. But now I can refer that as integral. Now I can describe this beautiful factorial symbol with the integration. So this is called a gamma function. So and obviously in the test, they didn't mention that this is a gamma function. But now we realize why they asked me to analyze this interesting looking function with the product of the polynomial and exponential, because they wanted to show you that, oh, this is actually something with the the gamma function, and they didn't mention the name, but it's the investigation for that. So that's great. Okay, this is great. And yeah, and then if we realize, if your teacher, for example, supposedly your teacher in the class told you, oh yeah, you know what, this question is actually not, we're not just interested in solving it, we're actually interested in why this question was given, and then why this question is actually very popular, and it's actually something to do with the gamma function. It's a representation of a factorial in an integral. But there are so many different ways of representation, such as in a limit form, and as a product form. This is an infinite product. Okay, these are very, very also nice topic, I think, for the internal assessment. So the reason I brought this up was to show you that these questions were actually carefully chosen, and then because of that reason, if you actually write an internal assessment on them, it will turn out to be very good. Why? Because this is what exactly IB wants, because they actually gave this as a question. Okay, it's not an overkill, it's not an underkill, it is just as good as it gets. Okay, and then yeah, look, the function looks like this. And then if you ask me, okay, why is it such a big deal? Well, now, for example, if I put z as a, for example, half, that gives you a very interesting factorial, doesn't it? Because it gives you -1/2 factorial, and we didn't know what it was, because for the factorial we learned it from the permutation, which was something to do with the arrangement of a real object, right? But now if I use that definition into this form, they are telling me what's the number of arrangement of a negative too many object, and which does not make sense. But now we can actually compute and give algebraic value using the integral. Okay, so yeah, if obviously you can definitely go over that. Okay, but let me continue. Let me show you other paper 3 questions from the other exam paper and then tell you why it was given. Okay, in the paper 3, November 2022, the question number 1 was talking about something with the power sum. They were interested in the the sum of integer square. They were interested in sum of integer cubic, etc., etc. So what we typically learn in Korea, okay, it's in the syllabus that the sum of integer square happens to be. Do you remember? Do you know what the sum is going to be?
No.
Sure. It turns out to be n plus 1, 2n plus 1 over 6. We often memorized, but in this question, they try to derive it. Okay, and then what we often do is to derive it for sum of integer, or sum of integer square, or sum of integer cubic. That's what you often do, and that's where the exam question finishes. But for your internal assessment, what you can say, oh, hold on a sec, I was solving this problem, and it was actually quite interesting use of binomial expansion and some algebra with the series, sequencing series, and hence deriving the general formula for the sum of integer square, and integer cubic. And I wonder if I have a general form of, let's say, integer power 5 or integer power 6. For example, if I wanted to generalize the formula for 1, 4, 2, 4, 3, 4, goes on and on and on, and to the power 4, can I derive the general formula? It can be a very good IA question, you see. And yes, actually, there's a name called it. There's a name of such theorem, and then it's always great to extend from a question. Right, so paper 3, November 2022, is something called the Faulhaber formula, which uses mainly of the binomial expansion and an extension of a series. But when we look at that, there's another very interesting number called the Bernoulli number. It's also very popular for IA. So what I'm trying to show you here is that these exam questions were not just chosen randomly. They contain a very deep history of math, as well as a very interesting topics to discuss. And then this is always exciting to write. And yeah, from the exam question, we can extend to Faulhaber's formula. And when you talk about that, there is something called a Bernoulli number, and this is also a superstar. And then another very nice example to associate this Bernoulli number for the IA, I would say something with the Maclaurin series, or something called the Basel problem. Basel problem is the one famous famous question of finding the sum of the following, right? So the 1/1 square, 1/2 square, 1/3 square goes on and on and on, plus 1/n square goes on and on and on. And Euler proved this to be the pi square over 6, and there are many proof of it. But working with this exam question from 2022 November, and then work with the Bernoulli number, you can actually prove this very nicely. Okay. And then have you done the Maclaurin series before?
No, I haven't.
Oh, okay. So here's the thing. Are you HL student or SL student?
Yeah, I'm an HL.
Good. So you'll be learning, all right? So have you seen the exponential function described as the power series, such as a 1 plus x squared over 2 factorial x cubic over 3?
No.
Sure. So you'll be learning this very soon. Okay, it's in your syllabus, all right? And then you get to learn these functions in infinite series described in such way. But so sine function will be given as, let's say, it's an alternating series, and then it's going to be the odd term only. So this is something we learn, okay? But then what you do not learn is the Maclaurin series of a tangent. We do not learn the general formula of the Maclaurin series of a tangent. We do learn the general formula, for example, exponential, log, sine, cosine, etc. But we simply do not learn the tangent. And there's a reason, because it's actually way more complicated. And there's something called the Bernoulli number that helps us to describe the general expression of a tangent. I think it's also a very good idea to write on. Okay, so let's move on to the next question. Paper 3, November 2022. Question number 2 was something with the surface area. It was something with the surface area. In the question, okay, they ask you to use it. They ask me to use this formula to get the surface area of a revolution. Okay, so that is great. So they asked me to use it only in the test. But if I have to use it for the internal assessment, what do you think is going to be the more interesting part of me being able to use this formula? Or what do you think the emphasis is going to be if I have to deal with this surface area formula? Sure, during the test, it's just a 1-hour test. You have to do 2 questions on paper 3. So you have a limited time, and it would be very rare to prove such formula, right? Any integral rule that you like to prove, you have to associate with the Riemann sum. Of course, it takes time. So in the test, you do not prove it. But for the internal assessment, you don't simply use the formula, you must be able to prove it. So, if I were a student and I decide to write the surface area, I would say, oh yeah, I was attempting this question number 2 from 2022 November. It was talking about the arc length formula, and it worked, because if I tried to use it on the sphere, it gave me 4 pi r squared, which is the surface formula that I know of. But I wanted to actually get in deeper. I wanted to see if I can actually prove this integral rule. And then whenever we try to use the integral, we use the Riemann sum. So then I wonder if I can actually prove this by Riemann sum. And that is a very good approach to start. That's a very good start of internal assessment, because it shows your personal curiosity, personal engagement for such topic. So yes, it's another very good topic. Being able to talk about how we can prove, how we can derive it, and also be able to use it for other shapes, such as this type of shapes is also very popular shapes in physical world, and that's another transition you can make from this exam paper. Sure. So if I have a look at the May 2022, it does not mention anything about the special feature about this equation. It's just ask you to sort of investigate. As you can see, the tone of the questions are very much like the math portfolio in the past. Because as you have seen from the math portfolio, what they do is they give you a question, they give you a topic, and they give you direction to solve it. But it was in a more narrative to make you write, but paper 3 is more narrative to make you solve. So obviously they will give you less hint, I think, in the portfolio, because you have to actually spend time researching it. But in the test, they need to give you more hints, because you need to solve it under the time pressure. And then you know, but here it does not tell you about what the name of this topic is, and this is actually called the elliptic curve. And it's one of the superstar. It's one of the superstar of the number theory. And you know, let me ask you. So imagine that you wanted to write this topic. So obviously you don't have to know anything about it yet. If you decide to write a question, if you want to extend from a question on, let's say, paper 3, what would be a good start to, you know, begin the writing? You know, what would I say in the beginning of my paper?
Any pre-existing theories?
Sure. You know what I would say? Oh yeah, I was solving this problem and it was super interesting. And I researched. Who researched? Did someone ask me to research this question, or who researched?
You did. So it's
Very good.
personal engagements.
Yes, that's the only part, to be honest, frankly, let me tell you, that's the only part you can show your personal engagement. Personal engagement, I think, can be thoroughly shown, and most of the personal engagement will be definitely shown in the introduction, because for the exploration, it's all existing math. You do not write anything new. Anything you differentiate, anything you integrate with, it has been already existing there. So it's not really the room for the personal engagement, but how I chose this topic, how I'm starting to talk about this important historical facts, historical mathematical idea, that is where you can show your personal engagement. And that's the time where you have to spend most of time to make it authentic, rather, instead of saying, oh yeah, you know what, I was watching a video about, let's say, cryptocurrency, and then they rely on something called the elliptic curve, and I like to talk about it. Okay, it may be an okay-ish introduction, but to me, it does not feel that much of a personal engagement. If you wanted to write the elliptic curve, and it's something to do with the cryptography, and it can be extended to the cryptocurrency. The Bitcoin uses this elliptic curve. What I would say is that, yeah, you know what, for this paper 3 problem, I was solving it, and then depending on the value of A and B, look at this, you know, now A and B are just a constant parameter, and as you can see, they ask you to sketch this, you know, they ask you to sketch this. So if I actually quickly sketch this, as you can see, depending on the parameter, depending on the constant parameter of A and B, the shape changes. Okay, so that's interesting. So let me show you another question that goes different shapes like this. Look at that. So it's got just a curve, but it's got a little tip here. Okay, that's interesting. And it's got a loop here. Okay, now it's got a detached loop. So as you can see, even though it looked exactly the same equation, depending on the sign and value of those A and B, the shape really changes. Now, of course, you can talk about what causes it, right? What causes it? It's so cryptic. It's a very mysterious, and discussing about that is just genuinely showing your personal interest, aka the personal engagement, and that's what you want to really dissolve most into for your introduction, because then later on, after that part, after the phase of introducing the introduction with your personal engagement, the rest is just history. The rest of the document has been already written for centuries, so you don't have to worry too much if you open up very well, because then everything will follow automatically, because elliptic curve, for example, is just so popular that you can never be wrong, right? But you made it sound more interesting because you got the idea from the paper, and then you research a bit more, and then realize it's something with the cryptography. And yes, the cryptocurrency, such as a Bitcoin, relies on this elliptic curve. And okay, what is so cryptic about it? How does it actually decipher, decode, etc.? Can be a very nice discussion. Okie dokie.
Okay.
So what I'm telling you to do is that you have to sound interesting. We cannot just write a paper, oh, I got this idea from this book, I got this idea from the video. We need to show that we are willing to explore. So that's another question. Yeah, you know, I'm just trying to show you every possible paper 3 questions for the, you know, internal assessment, because they're very good. They're very good. So here, you know, it does not tell you what this function is. It's called a hyperbolic function. It's a hyperbolic cosine, and this is a hyperbolic sine, right? And it looks like this. We read it as a sine and cosh. And it's mixture of a trigonometry with some interesting trigonometric identity, as well as the representation of that as an exponential function. And this is actually very interesting because if you look at it, sine and cosine with some extra h now associate with an exponential function. We often didn't see that. Well, we did actually see that because in topic 1, you also saw the mixture of exponential function with the trigonometric function as the following. So this is in our syllabus. So this is just another representation of a connection between the exponential and the sine cosine. And yes, if you are interested about this connection, you can always, extend a bit more. And then I just wanted to mention that the paper 3 November 2021 question was something to do with the hyperbolic function. And it's always nice to have a keyword, because now if I tell you about the keyword hyperbolic function, and if I tell you some example to write about, such as a catenary or a complex analysis, students then can do the explore. Right, they can then now, instead of having nothing or not knowing what the topic was behind this problem, knowing that would definitely shorten the process of finding a good topic, because now it's really limited within this, for example, hyperbolic function. So yes, what this catenary means is, golden bridge, for example. If you look at the bridge extension, right, and the bridge extension looks like this, and when we try to analyze the shape, what we often say is, oh, this may be parabola, right? Parabola is something to do with associate with the quadratic function, but it's not. It's actually to associate with the something called the catenary, which is from the hyperbolic cosine function. And then you will say, okay, why, right? So if I were to write catenary for my internal assessment, by the way, this is too popular topic, so I do not recommend people to write about the catenary. But if I had to write it for my personal engagement, I would say, oh yeah, you know what? I was just solving a problem in the paper 3 November 2021. And it gave me a very interesting function to link the exponential as well as the trigonometry. So I just wanted to know if it's got any name. And it turns out it does have a name, which is called the hyperbolic function. But you know what? Every function has a role. You see, sine and cosine is a periodic function. So whenever we have some periodic nature, such as oscillation, we use a sine function. Okay. And then whenever we want to talk about, for example, change of a temperature, we use, for example, an exponential function. When we want to talk about the earthquake and magnitude of earthquake, it's too large, so we want to scale it down. So we use a logarithmic function. So every function can be applied in real life. And now I have learned this new function called the hyperbolic cosine. I wonder if there is any real life application to it. And the little simple research actually led me into an application of a hyperbolic cosine, something called the catenary. Oh, that's interesting. I like to jump right in and talk about how we can actually derive this function more mathematically, more in terms of a calculus. Is the sort of a tone of what you want to do for your introduction. Okay, so you always have to show that you did it, nobody told you, you wanted to know about it. If you get stuck, no problem, you do the research, and then we can carry on. Okay, so whenever you try to write the internal assessment, you need to make sure you already know the answer. You already know what the paper is going to be with 100%, but you start pretending to be, naive. Oh, you know what, at the moment, I know nothing about it. And then I would probably take each step carefully to see what's going on. But that's just an act. When you write, you must know the answer so that you tell the reader what the story is going to be like in an interesting way. So we cannot be clueless before writing the IA. Okay. Oh, sure. This is also a very nice question. It says a paper 3 May 2021. It's one of the very first problem for the paper 3 after COVID. And they gave me this very interesting function. It gave me x to the power of n, a minus x to the power of n. It's very, very nice. It's called the auxiliary function. And then this function is often used in number theory to prove something of a transcendental things. You don't have to know anything about that. But if you are interested in proving, let's say, E is irrational number, this function may be used quite often. Okay. And so here's my question. In topic 1, there's a deductive proof. And there's something called a proof by contradiction. And there's a very typical example. If I ask you to prove is square root of 2 is a rational number, what do you do? Uh-huh.
Like, can I put it in the calculator?
No. Because the topic 1 proof is about the logic. You have to. So, for example, if it's a proof by contradiction, what we do is the following. We say, suppose, what's opposite to rational? It's rational. Right. So I want to call it as a fraction. But you know what? Whenever you write down the answer, it has to be very detailed because it's a proof, it's the logic. So you know what I'm going to say is the following. I cannot just say root 2 is a P over Q. I cannot say that because this is a very popular example, by the way, when you learn the proof, so we must know. But for proof, you have to write very carefully. So here, I wouldn't just put it as a fraction. You need to say, oh, and by the way, P and Q is, what is it? An integer, okay? And Q cannot be 0, and I want them to be co-prime. That means it's most reduced fraction. If it was a half, I'm not saying that 2 over 4 is allowed. I will try to divide as much as I can so their common factor is now reduced to be just only 1. So those are the definition I need to say. And if I just fast forward, if you square both sides, then you get 2 is equal to P squared over Q squared. So if you rearrange this to the other side, 2Q squared is equal to P squared. So hold on a second, look at this. It says P squared is a multiple of 2. What do we call an integer that is a multiple of 2? What do we call them?
Is there a terminology for it?
Come again?
Um,
What do we call a number that is a multiple of 2, such as 2, 4, 6, 8, 10, exactly.
even numbers.
Thank you very much. It's an even number. Good job. So look at this. If I multiply myself and I get an even number, that means the P must have been what? It must be also even because the product of odd number itself is just odd. So P squared isn't even. That implies P is also even. Okay, that's great. So what you would do, what you end up showing is Q is also even. After a few more steps, you will show Q is also even. But that's a contradiction. That does not make sense to me because I said they're co-prime. That means their common factor was 1. But by assuming square root of 2 is irrational, I led into something false. So that's what you usually do. That's what you do when you want to prove, such as root 2 is irrational or log base 2, 3 is irrational. You do this type of suppose is irrational and use a contradiction technique. But what you do not learn in school, okay, is that prove is irrational or pi is irrational. We don't learn that in school. Although, we don't learn how to prove it. We only accept this as a truth. But it's actually quite interesting. And there are many ways of proving it. But of using the exam question of May 2021, they give you direction of it. And using this function, you can actually prove it very nicely, also by contradiction. So what my point here is, yes, we can always extend from what already has been written in the exam paper, and it's already got Bible. The exam question that was challenging, it was like a Snape, Professor Snape, but now it turns out to be a good figure. This question actually gave me the half completion for my internal assessment because I already know what I'm going to talk about. I just have to make it more sound interesting or more personally engaging. That's all I got to do because they already gave you the steps, you see. So for me, if every time if someone asks me, okay, what topic should I write about, I just tell them, just have a look at the exam questions. There's so many great examples behind it. So if you're interested in working with the E or pi being irrational number, I suggest the May 2021 question is great. Okay, but you know what? We don't have to be obsessed with paper 3 because paper 1 and 2 also got killer 문항. It's got many great questions, but there's a reason for that. There's a reason why that question was made because they want to pay the respect of what already has happened in the past. That is a very, very important concept. So let me quickly show you right in. All right. So yeah, May 11 question. There was this very nice equation that you had to use implicit differentiation to talk about the tangent, but this is something with the envelope curve. There's something with the envelope curve. I wouldn't get into too much details right now. I just wanted to show you what is a associated topic. So this video will be shared with the other students as well. So for those of you who are interested in the differentiation and for your internal assessment, this is also a very nice investigation. A very, very nice investigation. Well, okay, let me move on. Okay, another question. Oh, wow, the May 11 was a good old year. You had to use this shape to derive this inequality, right? The sine theta is less than theta, and then it's less. Theta is bigger than sine theta, and then less than tangent theta was some sort of inequality that you had to derive from the May 11. But this is a very important inequality. And then the function to associate was, if I divide by the sine theta on both sides, you get 1 theta over sine theta, and then cosine theta. But if you flip everything, what you get is sine theta over theta is bigger than 1 over cosine theta and less than 1. So this function, the sine theta over theta, is very interesting. Because they wanted to investigate the sine theta over theta, they give you this question, right? So it's not just twisted random example. It's always something to link with an idea that we can definitely use for the IEA. It looks like this. So it's an alternating function. It goes positive, negative, negative. But as you can see, look, the amplitude is getting smaller and smaller. It converges to horizontal asymptote, okay, of 0. But there's another, but that question also appears again in 2016. But forget about anything else. Forget about it. But here's the thing. Look at this. When I integrate this, the aim of the question was to integrate this sine x over x dx. But I want you to check it out. It says it's something with the it was something with the 1.65. Okay, it was something with the 1.65. So if I integrate this, now I'm trying to find the area. So we were trying to figure out the area to the right, okay? We are just finding out the area. And then as you can see, we had to show that it's actually less than 1.65, but it's very close to 1.65. And here, if you compare this as, let's say, let me do pi over 2, it's it's not exactly the same, but pi over 2 is less than 1.65. And then in this problem is very popular with the integral. This on the right hand side actually converges to pi over 2. So in fact, this is an even function because it's symmetric by the y-axis. It actually ends up being pi. So integral of this function with the limit from negative infinity to infinity becomes pi. Okay, but what you really want to do is y. Why does it become pi? So in the exam, you simply solve it because they give you all the steps. But for the IA, what's the fundamental question is why is it pi? Is way more important. Okay. But you know what? In the exam, they actually give you the steps to use. So I think that's really nice. I think it's really great because in this question they give you the steps. So I simply have to write that as an essay style, and then I guarantee that this is gonna get you a very high score if you decide to write. But yeah, I'm just trying to show you why these questions were given because they are very interesting in the mathematical history. So yeah, there's another problem from 2004. You had to work with this strange function, which was a composition between the cosine and n times arc cosine x. This is not cosine of arc cosine x. This is a cosine of n times arc cosine x, and you have to show what's gonna be when n is equal to 1, n is equal to 2, etc. So, and then after all, you have to show by induction that it becomes a polynomial of the degree n. And if I quickly show you the list of this function, look at this. And if I put n equal to 0, 1, 2, 3, 4, 5, 6, on and on and on, it becomes a formula like this. And then this actually is something to do with the angular formula. If you think about, this is actually something with the cosine 2 theta. This is actually cosine 3 theta. This is actually cosine 4 theta. So this actually also works with the angular formula for the trigonometry, and this is how we can generalize compare using the coefficient of those polynomial with the angular identity. So yes, all those polynomial looks like that. But here's the thing. What do you think this boundary is going to be? If I, this seems to be somewhat limited, but look at this. If I try to sort of draw a shape that goes around the boundary of such polynomials, what do you think we are completing this as? What shape does this look like?
It's a circle.
Very good. But here's the thing. I mean, this is what I noticed in the question. But for the IA, what you must say is why. Why all this polynomial in that given domain will be within the circle is also excellent question. And you know what? What's gonna be a pattern? What's gonna be a pattern that just touches on the circle with that polynomial is excellent internal assessment materials. Okay, it's all hidden. It's all hidden in the question. If you choose the question well, you can always write something great. Good. So yeah, I wanted to continue with the with an example question from 2023, which has something to do with the combination. But maybe I will talk about that next time because I think it would take too much time. But today, I simply, you know what? I threw out many hardcore names, right? And obviously, you don't have to know absolutely anything about it because these are actually harder topics. It's something you learn in college. But I'm telling you, there's a reason these such questions were given, okay, on the exam because they low key, let me use the NZ word. They low key want the students to actually write on their internal assessment based on that exam question because it's got the history. Okay. So you know what I want you to only learn from today is if you decide to write an exam question for your IA, I want you to only remember one thing: how you can show your personal engagement from the question. What would I start if I decide, for example, working with this something called the Chebyshev polynomial? It's called the Chebyshev polynomial. If I wanted to write about it, what do you think how I'm going to start my IA? I was solving this problem, and this was actually really interesting. It gave me an interesting polynomial that has the coefficient as the double angle or triple angle identity of a cosine. That is interesting. And what did you do? Not only deriving this formula, what would I do? And every time for math, if you got a function, don't be afraid of plugging into what?
Plug into X.
Plug it into the graph. Why not? We want to visualize. Everything is about the visualization in mathematics. It's about the representation. And we did so. But you know what? It didn't give me some random polynomial, but it gave me what? A very interesting polynomial. It seems to be within the circle. Oh my God. Exciting. I want to explore this. Is the attitude we should have for the internal assessment introduction for the personal engagement. Okay. And usually I would say exam questions are Professor Snape. It looks like it's menacing, but it's very kind, it's very helpful. We just have to get into his tears to get to know what's really behind that question. Okay.